Can people see this as full screen? Is that right? Great, great. Thank you. Thank you. Thank you to the organizers for having me. I really appreciate it. Thank you for everyone for showing up. I wish I was there. I wish we all were, but it's been a really smooth conference so far, and I've really enjoyed tuning into these sort of individual sessions. It's the first one of these I've done, actually. I mean, we've done lots of these Zoom talks, but I haven't actually gone to a conference yet like this, and I found it quite interesting so far. Today, what I want to talk about, sorry, just get my own timer going here. Today, what I want to talk about is studying lexical change in modern English, and doing this using really large corpora, but specifically to really focus in on short-term language change. So when I say short-term, I mean over the course of like a year, language change on like a day-by-day basis. And I kind of want to make the case that this is a really unique and productive way of doing historical linguistics, a kind of a new type of historical linguistics. Okay, great. So, I think I just want to start by saying, oh, sorry, the slides are there. If people are interested in the slides, I'm not quite sure how well everything will come through. So if you want the slides, they're all linked there. You can get them in kind of full high def, that tiny URL link there, 2M3BKW7S. So basically what I want to sort of talk about today is about studying language change, which is obviously, one of the main areas of research in linguistics, really. I mean, been going on since before linguistics was a field. And I think, at least when we're talking about language change, modern empirical approaches to studying language change, and especially like language change within one language, like English, there's sort of two dominant approaches. The one is using corpora, using historical corpora, so corpora where the texts have been sampled over time and where you can then look at real-time language change based on actual language use. Not all historical linguistics, even of that type, sort of sees itself as a type of corpus linguistics, but I think it is fair to say that as far as it's drawing on natural language usage data and building these samples and then trying to observe patterns, that's sort of corpus linguistics. And then there's the other approach that's quite common in variationist sociolinguistics, where generally it's based on interview data, sometimes on surveys, sometimes on corpora, but where the historical pattern, where change over time is inferred from apparent time differences, right? So this is when you use age as a way of sort of trying to estimate language change, right? So if you notice a difference between older and younger people, then you can posit that a language change has taken place. And both of these are really, powerful and productive areas of research. I'm in no way trying to be critical of them, but they both do kind of have a gap, right? And the gap is, or at least one gap that they share that I'd like to try to address today is that they're not great at looking at really short-term language change. And what I mean by that is language change over, a period of days, weeks, months, years, not over eras or generations, but over really short periods of time. And clearly that's just because the data doesn't allow you to do that, right? Like with historical data, you just don't get that dense of sampling of texts. And with apparent time, I mean, you can do apparent time, it generally takes a fairly narrow focus temporally, but you can't compare like the difference between the language of people born in July 1979 and August 1979 as a way of trying to get like kind of monthly language change patterns. And the reason that this is important, right, is because the actuation and the initial diffusion of language change of linguistic innovations is a really quick process. I mean, we know, and you'll see today, that language change happens at quite a fast rate. And it's so fast that if you really want to kind of see it starting and really watch it emerge, and not just kind of the long-term process, but the short-term process, you really need a lot of data, and it's something you can't do with sort of these more traditional approaches. And this is especially true when we're looking at the lexicon, which is incredibly complicated, tons of words, most of them very infrequent, and where change can happen really frequently. And so that's kind of the goal today, is to really kind of show you what you can do with short-term lexical change using really big data. And the approach here that I'm kind of applying, or kind of a general term that we use to describe this kind of research, is computational sociolinguistics. It's basically using very large corpora of contemporary language. They're very densely sampled to study language variation and change, and in this case, very densely sampled over time. This primarily comes from social media, because that's the only source of this kind of amount of data at this time. But it doesn't need to be restricted to that. This is just kind of the most accessible source of data for really high resolution research on language variation and change. This is basically the approach that Bruno discussed this morning. I mean, to me, Bruno is one of the sort of originators of this field. And I think it really is sort of a direct extension of real-time corpus-based historical linguistics of the type that Terttu Nevalinen does, who's also speaking here today, of course, or tomorrow at this conference as the final plenary. It's directly inspired by Terttu's work and her colleagues and other people doing this kind of historical sociolinguistics, corpus-based sociolinguistics. I was at the last ISLE in London, and I was there for John McWhorter's plenary, and I think he said he was talking about a Creole view of English, if I recall. But what I recall is he said something like, 20 years ago, it was only a few people in Finland who were doing this kind of research or who thought this was possible. And I kind of feel the same thing here, right? This is kind of research that, largely come from Finland initially. So I think it's fitting to be here, and I'm really glad to be a plenarist along with the other three speakers. The last point I want to make before I kind of get into this is just that, this research in computational sociolinguistics and looking at really short-term, high-density language change is something we can only do in a few languages. And English is probably the main one. Spanish is another, as Bruno pointed out. There's not really many others that we can do that with. And, I think there's a lot of discourse about kind of how too much of linguistics focuses on English. And, that probably is true to an extent. And how there's lots of insights that we gain from looking at typologically diverse languages, and that's obviously true as well. But the kind of research that I'm going to show you today, and that Bruno showed you earlier today, really can't be done on these other languages. There's something special about languages that have massive numbers of speakers, and there's something special about being able to access that language at scale online, and it makes this kind of research possible. Presumably more languages we'll be able to get access to like this in the future, but certainly not all languages. And I think it's an interesting time to be doing English linguistics, to be Anglicists, and to work on this kind of data. It's a kind of a new frontier for doing this kind of research, and I think it really does have the possibility to sort of revolutionize how we understand language variation and change. Okay, so to get into the specifics here, today what I really want to do is try to kind of like demonstrate the value of a really big data approach to the study of language change. I'm going to present some new research. I'm going to review some of my recent research on lexical change. This is research that was initially published in English Language and Linguistics, which I guess is the sort of journal of this society, or associated with this conference. And then there's also a Jengle publication as well. I'm going to review that in the second half of the talk. So I'm going to start with unpublished research in the first part. And what I'm specifically interested here is in trying to understand short-term lexical dynamics, so how words, the frequencies of words are changing over time, like I said, on a very short term, basically a year on a day-by-day basis. So that will be the first part of the talk. And then the second part, I'm going to zoom in and really focus in on lexical innovation and look at that on a systemic level, meaning, not just individual words, but change within the whole lexicon, or looking at words, a number of words in the lexicon. This is all based on a single corpus, a very large corpus, a corpus I've worked with a lot. It should say there from 2013 to 2014, but it's American Twitter. It's about 1 billion posts and about 9 billion words. I believe it's the largest of these corpora that are being used this way. And crucially, every text is time-stamped right down to the second, so allowing for really high definition historical research. And then geolocated down to the meter. So every one of these is also geolocated. And that means that we can really do some really detailed analysis here in a way that wouldn't be possible otherwise. And I guess the last point before we jump into it is that I just want to make is that, given such a large corpus, one might think that the methods need to be super complicated. You certainly need some computing power to do this, but the methods themselves don't need to be especially complicated. Everything I'm going to do today is based off of a really simple idea, and that is that we can measure the frequencies of words over time. And basically for any word in this corpus, I can give you a time series, which shows you day by day how frequent or infrequent that word was. And that's the starting place. That's the data we're working with. There's a bunch of these time series. They're just relative frequency of the word over the days of this period. There's 399 days there. There's, I have it on a later slide. There's like 60,000 words or something like that. This is basically like Google Ngrams, right? So I think we've all seen this kind of stuff. We all know those Google Ngram, Google Book trends. The difference here is just that instead of being over 200 years, this is over 1 year. So it's much, much denser. It's also more controlled. We know exactly where the data is. It's all quite comparable. It's all geolocated American tweets, and it's less opaque because, you know, I can go into the data and look at what's happening. Okay, so that's the basic idea. And here's what kind of the data basically looks like. I'm going to walk you through this one here because we're going to see a lot of these, and it's just important to get that basically these are the observations. This is the data we're looking at here. So this is a time series for the word I. I is the most frequent word in this corpus by quite a long shot, which is remarkable, I suppose, because the is usually the most common word in an English corpus. But on Twitter, I is, I guess in part it reflects a kind of a personal nature of Twitter, but I think more what it reflects is a highly informal nature of Twitter, right? Lots of pronouns are associated with more informal language. So that's the feature here. And then what we get is a graph that shows you over time how the frequency of this feature has changed. So your x-axis, your horizontal axis is a timeline. There's basically a point there for every day. It runs from October 2013 to November 2014, so a little over a year. Like I said, there's 399 days there. And then on the y-axis, the vertical axis, you have how frequent the word is. And this is, like I say, the most frequent word in the corpus. And then what you can see, right, is how the frequency of this word has changed over time. And so in particular, you can see two things here. One is that broadly speaking, I has been over the course of 2014 at least was falling in frequency, kind of in two waves there. But, you know, broadly speaking, kind of this gradual fall over time. So that's the one pattern you can see. That's the kind of global pattern. And then the more local pattern is this sort of jagged edges. And that's fairly regular. And what that basically shows you is that the word I is used less on the weekends. Consistently. So you get a jump every week. On the weekdays, it's it's higher. On the weekend, it's lower. That's why you get kind of these sharper points on the low end. And so you can see both of these patterns happening. You know, presumably, and I think as we move on through this talk, you'll see reflecting kind of Twitter becoming maybe a bit more formal over time, at least during this period. Here are a few more. So here's the frequency for the word frequency time series for the. This is the second most common word in the corpus. And you can see here that there is this sort of local pattern, this sort of cyclical pattern, which is basically that the gets used more on the weekends, or at least near the kind of near the weekends. But otherwise, you can see it's fairly stable. You know, there's obviously some fluctuation there, but, you know, probably not much to say about that. It looks like it's actually fairly stable. A bit hard to distinguish here between sort of randomness and a motivated change here, but it looks basically like things have stayed the same. You will notice here as I go through these that the y-axis changes. It keeps scaling to get whatever feature I'm looking at. So here's another one. This is kind of just a proof of concept. I want to include this in here just so we can see that, like, you know, these aren't just random things. These are real patterns. So this is the frequency of the word moon, and what those spikes are, of course, are full moons. And what that big spike is in, I guess it would be April 2014. I guess someone could fact check that. I think that there was a supermoon that day, and so you can see that these spikes don't just reflect when the full moons are, but like the magnitude of the full moon. And you can also see, I think, kind of neatly here that after the full moon, after this supermoon, sort of the moon discussion actually kind of went up in general. Those spikes tend to be higher than before. Here's another one. So this is the time series for hot. And I'm just kind of showing you here, there's not much, I mean, there is obviously local variation, but there's not like a clear kind of weekly trend there. But you can see that it rises up in the summer. Similarly, you can see that warm goes down in the summer. So you can see those are almost kind of in complementary distribution with each other. And then here's cold, which you can see shows a very similar pattern to warm. Okay, so again, cold is higher, or it peaks there in January, as you can see, lowest in the summer months. Okay, so those are all just kind of show you that this, you know, makes sense more or less. I'll come back to some of these examples. One more of these for kind of fun. So here's linguistics. And now this looks fairly random at first. I mean, you can kind of see there's some ups and downs. Hard to maybe see exactly what's happening, but there's definitely something happening here. And we can see this more clearly. You can also see this is a very infrequent word, so generally less than 1 time per million words. And so this isn't the most sort of reliable time series. But when we take a slightly more frequent field of study, here's physics. Now you can see the pattern very clearly, very similar and very clear. And you can see here that what's happening here is that it's used less often during the holidays, right? So around Christmas holidays, around January, and then in the summer holidays, you can see it's used less often. You can also see it's referenced less often generally on the weekends. You can also see a slight spring break pattern there in the middle of the screen, the kind of dip. And you can see this again if we look at university, we'll see something kind of similar. A bit different, you can see that people talk about university a lot more at the start of the term of the academic year, but again, you can see the same basic pattern. So these are just examples of these time series, and the basic idea here is that we have 67,000 of these time series. So in this corpus, it's like I said, it's a huge corpus, it's 9 billion words, so very, very large. There are 67,000 orthographic forms, so every unique string of characters is treated separately here. There are 67,022 of them that occur at least 1,000 times in the full corpus. And so I pulled out all of those and then generated a time series for each one. And this is the basic data upon which this entire talk is based on, are the time series for these 67,000 words. And so basically you can picture this like a, like a big collection of these time series of the type I just showed you. And so what I want to do here first is to kind of begin by exploring these general trends in the lexicon, time trends in the lexicon based on that data, on these 67,000 word time series. Before then, I'm going to zoom in on lexical innovation. So to do the first sort of part, by just looking for these sort of general trends in the lexicon and trying to make comparisons of time curves, what I first did was I just made these as comparable as possible. So what I first did was I smoothed each one of these using a 28-day moving average. So this kind of smooths out those weekly trends, so we can kind of look at the broader trend, right? We kind of want to try to abstract away and kind of focus in on the broader trends over the entire year. I mean, at least that's what I want to do here. You could certainly focus in on the weekly trends if you wanted. And I've also scaled them all, meaning that instead of having this sort of moving y-axis, they're all now measured between 0 and 1. So for every one of these words, its lowest frequency day is marked as 0. Its highest frequency day over the 400 days or so is marked as 1. Excuse me. And then everything else gets scaled in between. So the shapes don't change, but now we can look at all these shapes and kind of compare them directly on the same axis. Okay, and overall, what I'm going to show you here is that we see really clear patterns, often with really straightforward explanations for the overall time series of individual words. So when we look at individual words, like the ones I just showed you, we often see really clear patterns or sort of a clear lack of anything happening, like with the word the. But at the same time, what we see is what you might expect is like really massive diversity over these 67,000 words. And so, it makes finding general patterns in here somewhat hard to appreciate. And so I want to walk you through that here. So first, let's take a look at a few of the ones we've already seen, just to sort of show you what they look like. Maybe you have them in your head. So here, for example, is the 28-day scaled moving average for hot. You can see that a lot of the kind of local variability has been kind of smoothed over. And you can also just notice as we go through these that the y-axis, these scaled relative frequencies, they always sort of stay comparable here. So here's the one for hot, and then here is the one for warm. And what you can really see here is this kind of direct, kind of almost, mirror image here, right? So hot, warm, okay? And you can see they're really quite clear what's happening here. In the summer, people talk about being hot, and in the winter, people talk about being warm. We can also compare this against cold, and what you can kind of now appreciate with this 28-day moving average, which I don't think you really could before, is that, hot and warm and cold have very similar patterns. Here's warm again. Cold's very similar, but cold's a bit more pushed into the winter. And so you can really see that it picks up these kind of really fine-grained patterns. I'm not sure that's surprising, but I think if people are concerned about the kind of robustness of this or about the reliability or the meaningfulness of these kind of analyses, then this should give you some additional confidence. And then here's I, just sort of just to show the smoothed out one for the most common word. I should note that the kind of bit of squiggliness at the front and the back of these time series, I think, is a bit of an artifact of the smoothing, and we shouldn't make too big of a deal out of it. But what I want to show now is just how complicated things get. So this is the single most frequent word in the corpus. Here's its time pattern. kind of fall, we can say. Here are the 10 most common. Okay, so these are the 10 most common word types in the corpus. You can see I there. It starts it's the one that starts highest on the origin. But there's a bunch of other ones going on there too, and you can see there are some consistent patterns. You can, like, there's a bunch of falling words there at the end. This, I think, are a bunch of pronouns, if I recall, or more kind of conversational and formal features. But already this is getting pretty messy, right? Like pretty complicated to kind of try to see patterns here. So this is 10. These are the top 10 word types, the 10 most frequent. Here are the top 100. Okay, things are getting really pretty complicated. You can definitely see some little trends in there and stuff, but good luck trying to sort those out. That's the top 100. Here now is the top 1,000. Okay, you see things are getting quite complicated. What's maybe notable here are these sort of bands you can kind of see, or maybe you can see depending on your screen resolution, but there are these sort of vertical bands. And what those are periods of actual quite high instability where a bunch of words, not just one word, but a lot of words are really moving up and down a lot in those little time periods. That's what those bands show you. Here's the top 10,000 words. Okay, we're just starting to fill in all the space is the message here. And then here's the top 67,000. This is the full set of 67,000 words. Probably given Zoom's resolution here, you've probably just seen a blue box. If you maybe some of you are seeing a bit of sort of darkness in there, but you know, the point here is just this is, you know, a very complicated system, right? There are just so many words doing so many different patterns, so many words there in the first place. You know, it's a lot to try to make sense of. Okay, so given the number of words and this extreme diversity we see in these time series, right, it's difficult to try to like kind of intuit patterns out of this sort of tangle of time series. So, you know, what we want to do here is try to pull out, identify the kind of underlying patterns in here. And so to try to find these underlying common dimensions of lexical change, what I did was I took the complete 67,000 word time series and put them into a multivariate analysis, in this case, a principal component analysis. The method doesn't really matter here. You could do this with all sorts of different techniques. You find very, very similar things. And I don't really want to get into the details of the stats because it kind of doesn't really much matter. These are very robust patterns once you get in there. So you could do a multidimensional scaling, or, you know, some kind of, well, there's various ways you could pull common patterns out of this. Okay, so what I did then was I did this, and I can then pull out these sort of aggregated dimensions where each of them, where they're ordered by importance, and where each represents a common pattern in this huge set of words. The way I like to think about the method is something like this. Let's say we went through each of these, all 67,000. We had a time series for each one, like the ones I showed you earlier for warm and hot, and we put them in piles, right? So we put hot in one pile, and then we put warm in another pile, and then when we get cold, we put it in with the warm pile, right? Because they had such similar patterns. And then we get to I, and we put that in a pile, and then we put all the ones that are falling in a pile together. And at the end of this process, you could like stack up these like pages, right? Like literally, like say, you know, A4 sheets. You could stack them up, and you could say, okay, well, this is the most common pattern, right? This is the second most common pattern, the third most common pattern. That's essentially what the analysis here does. And what we can then do is kind of take the average of those patterns and sort of show you what is the kind of general time series pattern for words in this corpus, ordered in order of importance. We can also say these are the words that show these patterns. These are the words that are most strongly associated with each of these general dimensions. And we should also note that each of these dimensions will not just identify one pattern, it will identify like two inverse patterns. So so warm and hot would actually be on the same pattern, but on opposite ends, opposite poles of that dimension. So let me just show you some examples here. I mean, like I said, the kind of technical end doesn't much matter. I think it's fairly intuitive once you get into it. So this is the first dimension. It shows either a rise, it also shows the inverse pattern, so a fall of words over time. So this is to say that of the 67,000 top words, and I should have given you a percentage here, you know, the single most common pattern we see is either words that are kind of consistently rising or consistently falling. I don't think we should make too big of a deal about the kind of sort of more kind of local trends here. They probably aren't really all that meaningful. I also think the little curves at the back and the front of these time series are a bit kind of artifacts of the smoothing and stuff. But generally just this kind of increase over time. Like I said, we can also plot the words that show this pattern over top of it. So each of these little lines are some of the words that show these patterns. they're kind of listed there on the side just for the record. I don't expect anyone can really see them, but we see things like mute is there, selfie is there, low key is there, bayless is there. And we're going to actually talk about these words in particular in a lot more detail in the second half of the talk. So these are words that all show this pattern, and here are then words that show the opposite pattern. So you can see jerk there maybe is one of them, and then a bunch of laughter markers. You see bah ha ha, ha ha, a bunch like that. And I'll come back to these as well too. So these are finding that out of these sort of tangle of all these word time series, there's a whole bunch of words, not just the ones I'm showing here, like hundreds and hundreds, that show these two patterns, either consistently going up or consistently going down, broadly speaking. The second most common pattern is this one here. This is the school holiday pattern, which I showed you there with university and physics and linguistics. We also see here anthro, accounting, equations, writing. Okay, so these are words that show the difference between during the holidays and not during the holidays. And I think this sort of attests to how important this is for the community of Twitter users, which are often younger people, but just in general in American culture, just how important this kind of the work time and the non-work time are. I thought this was kind of a fun one. So these are the word that best shows this pattern is the word essay, okay, because it's clearly such a school kind of word, right? And then here's coughing tracked against it, and you can see that coughing and essay go together pretty well, except during the Christmas holidays when people keep coughing but they stop writing essays. But it's kind of remarkable just how well that tracks, especially through the summer holidays. I think it's also kind of maybe evidence for lockdown of universities, right? Like a lot of coughing going on during the term. Here's the inverse of that one. So you can see it's not quite as pronounced in the winter in reality. What these is a bunch of words that are really summertime words. So the ones you can see there, maybe they're like lifeguard, boaters, and kayaking, stuff like that. Okay, and then the third one is these sort of springtime words. So we get orchids, handkerchiefs, right? Allergies, asparagus, track for track and field. Okay, these are words that are associated with the spring, and then alternatively, here are ones that are not associated with the spring, that are associated with the summer and the winter. Scarves is there, for example, for some reason. Okay, so we can keep going with these. There's literally hundreds of dimensions that you can pull out. Each of them kind of just get more and more complicated. They tend to get very cyclical, and they start to get, as you go down, less and less explainable. But I don't really want to focus all my time on this today. I want to focus in on these two, and in particular, the top one. So these are words that were rising or falling over time. And we can see that these show some pretty specific patterns, right? So the words that are on the rise tend to be doing these things, at least at the very top end. We see a lot of these new word forms, things like bay and bayless, so things that are not yet in the dictionary. We see shifts on existing words like squad, slays, goals, lit. These are all words that have fairly well-known meaning shifts. So lit became to mean good or excellent, squad to be your kind of group of friends, stuff like that. You see a big uptick in acronyms, and you see lots of these kind of cultural trends, right? So things like apps, I guess, like Lyft or Time Hop, food and drink, so like saison, the style of beer, burrata, the cheese, horchata, the drink. You see fashion trends like choker. You see just kind of things that were in the news like Sharia law, I suppose. On the other hand, on the fall, you get all these laughter markers, you get interjections, you get a bunch of these insults, and you get all these creative spellings. And I think it's actually quite notable, like that those all kind of go together, right? Like there's a lot of stuff here on the fall side, which is kind of informal, highly informal language, and a lot of these are falling away. Some of them are getting replaced with other things, laughter and interjections by emojis, insults by newer insults, certain types of creative spellings with other types of creative spellings. But I think in general, we can see that it's becoming more formal and maybe more efficient too, trying to kind of maximize the amount of information we can pack into a tweet. I want to focus in though on the second half of the talk though on these words. So these are new word forms that are rising quickly. Now this work, although I'm presenting it first and it's the unpublished work, this is the unpublished work that's come after. And so I'm going to take a somewhat different method for pulling out these new word forms from the corpus, which was first described in the English language and linguistics paper. But it comes up with basically the same words, so it's sort of nice to see it in both approaches. We sort of I saw this afterwards and was and was happy to see it show a kind of robust and consistent result. Okay, so in the second half of the talk, what I want to talk about is analyzing lexical emergence. So this is work that was done with Andrea Nini, who's now at Manchester. He was the postdoc on the project, and Jiangsheng Guo, who was at South Carolina, a geographer who collected the data. And this was all funded initially by digging into data, a sort of transatlantic data science in the humanities grant that we got back when I was at Aston. There are two main publications off that. There's a few others kicking around, but if you're interested in this, the 2017 goes to the English Language and Linguistics article, and then the 2018 one is in Jengle and talks about mapping. I'll talk about that in the very end of this talk. Anyway, so the idea here is to look at emerging words. These are basically how we define them. It's our term. We just kind of wanted to avoid neologism because most of these words aren't starting on Twitter, so we don't really get their start in general. We get their start in this variety. So we use the term emerging words to be a term that refers to new word forms that are in the process of entering the lexicon in a given variety of language for the first time. So that includes both their kind of actuation, or as close as what we can get to their actuation, what we can infer about their actuation, and then their early diffusion. This is the kind of stuff that you can only get with these really dense corpora that are really densely sampled over time. To identify these emerging words, we just once again directly analyzed each of those word frequency time series, the unsmoothed versions here, although I don't think it would make much difference. And in fact, it might be good to work with the smooth ones in hindsight. And so we took these 67,000 most common words, and then we pulled out the words that met these criteria. One, we wanted to find words that were really infrequent at the end of 2013, right? So at the beginning of the corpus, we're trying to find words that didn't really occur at the beginning of corpus, right? Even that occurred not at all would be ideal. So for things that were occurring less than once per million words. And then we were also looking for words that really rose consistently over the course of 2014. And we did this just with a Spearman correlation, correlating rank of frequency against rank of day, and it had to be over 0.7. Again, these are really simple methods, right? Like there's nothing fancy here. These are just basic measurements that you could do in Excel. Making the measurements is hard, or at least takes some computing power. But once you get them, these things can be done very easily. We also then excluded anything that was a proper noun or that was already in the dictionary. And also for words that had lots of different forms, we just took one, like we didn't lemmatize, but we just took one word type per lemma, and it was the most frequent one. And then also what we can do here is, based on these two measures, we can really visualize the full lexicon and really show you where these emerging words sit. So here's the full lexicon. These are 67,000 words here. The starting frequencies on the y-axis, you can see I is up really high, right? Because it's the most common word. And then here on the x-axis, you can see if these words are growing, rising or falling in frequency. So words that are far over on the right-hand side are really shooting up in frequency, and words that are far over on the left side are really dropping in frequency. Okay, so this is taking the two measures we used and visualizing the corpus this way. And you can see, for example, that I is both very frequent and falling quite clearly, as we saw. The is the second most frequent, and is is kind of staying stable. And like for a word that's for words that are very common that are increasing in frequency, we see like in, from, on, of, for example. So those prepositions. Okay, so let's remove this, and what we want to do now is zoom in, because the words we're interested are down here in this bottom corner, a tiny corner. It's down here, right? These are words that are both very infrequent at first, so they're very low, and then that are really shooting up, so they're really far to the right. So we can kind of zoom in on this part. So let's zoom in here. Okay, we're going to just keep zooming in to this bottom right-hand corner of the screen. Okay, so zooming in here, you'll see just how many words there are down there at the bottom, right? This is the zip curve, essentially, right? There's so many words that are very low frequency, and this is why you need so much data. So we'll zoom in here now. We'll zoom in again, just this little bit here, right? So just this tiny little bit, and this is where the words that we're interested are falling. You can see, if you look up at the top there, you can see a lot of words that we would like exclude. Those are also maybe a little bit, so a bit too frequent at the very top of this. But things like time hop is an app, party next door is a singer, feminism is an existing word. So we wouldn't want to look at those. We exclude those. We want to really look in at these, at these new words that aren't existing words or proper nouns. So things that might get into the dictionary, you might say, right? Okay, so here they are. These are the 54 emerging words that matched our criteria. Again, one per lemma, okay? the most frequent. And here they are. They're kind of a mixed bag, which I think is good. You'll see words that you might recognize on here. You'll see lots of words you don't recognize. You'll see words here that are kind of weird spelling variants. You'll see lots of acronyms and stuff too. But these are just a kind of an unbiased sample of the words that meet the criteria as we've defined them. Okay. And the idea here now is that, we now have these 54 emerging words. Like, this now allows us to make generalizations about how lexical emergence works in this variety of language, with a level of precision that we couldn't have otherwise. Okay. It's not like we just hand-picked out a word that we were interested in that we noticed. It's not like we just have a couple words here. This is all the words in this huge corpus that match these criteria that we've set, that we say are both simple and kind of, meaningful and principled. And, I don't think anyone's ever really done this on any variety of language until now. And so this gives us a real new way of understanding lexical innovation. Obviously, it doesn't let us see lexical innovation in general. We're really looking here directly at Twitter, and that's all we can directly say as corpus linguists. But I think this is the closest we get to understanding at this moment kind of these processes in general, right? And I think we can sort of safely assume that to at least some extent, this is sort of like almost like a shadow of the bigger process of lexical innovation in American English in this time period. I mean, crucially, most of these words, even the acronyms, are not, localized to Twitter. Very few of them will, we think, even started on social media. Maybe some of the acronyms, some of the more techie ones. Okay, so we can look at this now from a range of different perspectives. I think it's kind of exciting, and we can try to then kind of see, okay, well, in general, what's happening? Because we have it's not a huge sample, but it's a big enough sample that we can start kind of making generalizations about, well, here's the most common word formation process. Here are the topical domains these are coming from, stuff like that. And we can start by just looking at the meanings of these words. I don't want to run too long. I'm not going to leave these up for a long time. Like I said, this is all, the slides are available there, and the link will be back at the end if you want them. But we see all sorts of things here. So things like am I right, which is just this kind of blending, smushing, compounding of a sentence. We get these bay forms. So bay is sort of a couple years old at this point, but that means like your significant other. So we get these forms like bayless, or you'll see unbay later on, which are like derivations of a new word. We get things that are related directly to fashion, like hairstyle, balayage. Boulin and brazy are interesting. These are both made by taking words that begin with C and replacing them with B. This is done by the Blood Street Gang, who doesn't want to use words starting with C because of the Crypt Street Gang. So this is total just social meaning marking, right? You get things that are like pronunciation, like bruh. You get things like faved, right, as a way of shortening this. Litty became really popular. It's one that's really stuck out well. Not all of these have stuck around. Fleek is a big one, we'll come back to in a second. Here are some others. Get ones like senpai, which come from kind of anime, manga culture in Japan. You get lots of ones here related to sex, get lots related to family and friends, lots related to drug use. There's Zans, for example, Xanax. There's unbay. You get lots of these acronyms like TFW, that feel one, which is still quite popular. Looking at these, I think we can start to talk about like, well, what is the actual motivation for these new words? And I think it's sort of an exciting thing to be able to do, right? Like in a really short time, what was motivating these new words? Why did they emerge? Why did they spread on Twitter? Why were they so popular and useful? And I think that's exactly what we can see here, is that we see that they spread because they're useful. They don't only get coined or get produced because they're useful. They spread because people need these to meet real world communicative needs. I think we can broadly see kind of four different motivations here. The most obvious one, I guess, is just to refer to new concepts, right? Like there's a new hairstyle, so we need a word to refer to it. There's this act of pushing like on social media, so we need a term there. But they also do other things too, right? Like they have some of these words come about because they have these kind of useful communicative functions, like for emphasis, right? So like the acronyms, for example, or am I right? Or even faved, right? Like it's shorter than favorited, for example, right? And maybe a bit more natural as a verb. And also for emphasis, like these sort of repeated spellings. They also mark meanings of existing words. I think this is maybe the most surprising one, right? That there's a lot of stuff going on in written informal language where you're spelling things in a non-standard way to mark a non-standard or specific meaning of a word. So gains, gains with an S is obviously a common verb and noun for that matter. But gains here means like weight gains from lifting weights and eating healthy, like for young men, right? So like teenagers have got good gains or something, means that they really worked out well. Lort is sort of a pronunciation spelling of the word Lord, but it doesn't get used like as a noun. It gets used as an exclamative. Or lit here, marking this particular new meaning of lit with the double T. And then lastly, although I think it's crucial to say this isn't the only thing happening here, you get these social meaning markers. So we talked about Boolean and Brazy, but things like bay. I mean, I think when we have these synonyms like bay, well, bay is actually one of our words, so I shouldn't have included this, but something like bayless or something, we have these synonyms like for the word single or for significant other that get really popular, you know, because we don't really need a new word for significant other or for being single. Or for yes, but they get used here to mark social groups, social meaning, social identity, and that includes both dialect spellings and then these synonyms. I think these four things are broadly pushing new words here. We can also look at these structurally. So here they are classified by word class. We get nouns, adjectives, verbs, interjections, and crucially these whole phrases. You know, don't really need to go through all these in detail, but I just want you to see the diversity here. And I want you to compare this diversity to the diversity of word formation processes. So we get compounds and blends, we get these spellings, we get derivations, we get acronyms, truncation, borrowing, conversion. It's all there. We even get one real legitimate coinage, meaning not produced by combining other words, and that's the word fleek, which as you saw, we really could map. Well, sorry, I'll come back to that in a second, actually. Okay, so then in terms of these properties of these emerging words, we see it's very diverse. We see compounds really common. We see creative spelling gets used a lot. But I think the one I really want to kind of focus in on is acronyms. I think it's really interesting, right? Because, and I've only sort of thought about this as I was preparing these slides, and that is that, like, you know, what word class are these, right? I mean, normally acronyms that take off in a language are things like NASA or CNN or something. These are proper nouns, and so they're kind of unproblematic as words because, you know, these are things that would be stored in the lexicon as words, right? But these aren't. These are like that feel when or am I right? Like these are not traditional words, right? So, but they are words, but they're not of a traditional word class. And this is sort of interesting, I think, because they represent these entire phrases and clauses as words. And I don't know if there's a good kind of analog for that or a good way of treating that. I mean, I guess maybe as a construction. Also, it's worth noting here that true coinages are rare, only fleek. And that's because they're constructed from existing words, you know, kind of as we would suspect, I think. But I think it's notable with sort of interest in iconicity that maybe none of these words, except perhaps fleek, is iconic directly. And that's because they're all created out of existing words. We can also look at the time series here. So here are the time series for a few of them. Here's that feel when, here's bayless, and here's fleek. It really shows you how we caught fleek in the act of taking off. And I think what I just want to point out here is that these are all S-curve changes. Okay, I'm gonna take about 5 more minutes and I wanna talk through now just kind of what we see happening over space as well. So we can look at the diffusion over time, but we can also look at the diffusion over space, and that's because we have, for every tweet, we have a geolocation. So we can then group all the tweets, and in this case by counties, and then we can map how the word spreads across the counties. And we do that by mapping the cumulative relative frequency across the counties. So on day 1, we map the relative frequency of the word in each county. And then in day 2, we map the relative frequency of the word on day 1 and day 2 in each county. And on day 100, we match the relative frequency of the word for all the tweets from day 1 to 100 in each county. And then we could look at these over time and see a change over time. We can also reduce this down to one map. I'm not going to go into the details here, but I'll show you the example here in a second. So here, for example, is fleek, and we're jumping in here in June because, as you saw, it took a while to take off. We actually know where this one kind of starts. It starts from someone in Denver, which you can see there, the one little part in the middle of the country, but they're from South Carolina, which you can see on the other end of the country over here. And you can see here it is, you know, very limited spread. This clearly didn't start on YouTube. In fact, we kind of know it started on YouTube. But here we can watch it start to spread, and we can see it spreading here through the south and the east, okay, down in this area. Okay, and then you really see it take off in August, take off in September. You can see it's really concentrated in the south, but spreading everywhere. Here it is in October. Here's November across most of the country, but you can see it's really concentrated in the south. Here's Atlanta, here's the Carolinas. And then here's our hotspot map. So this really shows you where the word was strongly being used early on. If you're interested in this, you could look up it in the paper. Okay, and then similarly, here's that feel when. You'll see it has less of a clear regional pattern, but also different. So not in the South as much, but more in the North and on the West Coast in California. Here's March, here's May, here's July, September, and November. And then when we try to kind of extract the underlying pattern here, we get something like this. So you can see it's really concentrated on the West Coast, especially in California, with sort of secondary clusters, especially up here in the Northeast around outside of New York City, actually. Here's a few more. So this is not looking at the whole series, but just at the kind of final kind of aggregated map. So here's Famo in the South. Here's Bayless across the South. Here's Lort across the South again, but now more concentrated on the Gulf Coast around Louisiana. There's New Orleans right there. Here's Litty, which has a less of a strong distribution here. It's actually now become very popular. It's one of the most successful words, but that really started off in New York City, it appears, at least on Twitter. Okay, so finally, we can talk then about the properties of these words from a geographical perspective. And much like what we do with the time series, we can look for common patterns here. So the same idea, it's not 67,000 things now, it's just 54, but we put those into, in this case, a factor analysis, very similar to a PCA, just different studies at different times. And we can find common patterns here. We found 5 main common patterns. We call these the hubs of lexical innovation. So here's the first one. This is the sort of general urban West Coast one. So these are words that really seem to come from the West Coast, but maybe kind of from across the urban United States. This is maybe the least kind of interpretable one in some sense, but you can see it really does align well with population density here. Okay, so higher white, more people. You can see just how well these align nearly perfectly. Here's the Deep South pattern. These are the words that are associated with it. Okay, a lot of African American English here, obviously, and here that one is. Okay, and you can see it's really concentrated there on the city of Atlanta, and otherwise spreads out across the South. And that really aligns well with the population of African Americans. Okay, so this is clearly related to African American English, like I said. Here's the Northeast one. So you see like the lit forms there. Okay, that's really associated up here with New York City. Okay. And then here's the Mid-Atlantic. So there's this another group here. This has like Shorty, Fuckboys is there. That's really strongly associated with like the Philadelphia, Baltimore, Washington, D.C. area, with kind of a secondary hotspot over in Chicago. Again, you can see this does align to a large extent with African American population, or at least partially. And then here's the last one. This is the Gulf Coast pattern with these forms here, including Lort. Okay, and then you can see that really centers in on Louisiana and New Orleans. Again, you can see that also corresponds to African American, well, to areas with high population of African Americans, and hence to African American English, at least it would appear. Okay, so just to wrap up then in terms of these emerging words, what we find, right, is that these words, at least from this period on Twitter, tend to originate from a really small number of hubs of lexical innovation, about 5 of them. And these are all centered on like cities of considerable cultural importance, right? So Los Angeles, San Francisco is the first one. Atlanta, kind of the capital of African America, if you I guess to say it that way. The Washington, D.C. Area, New York City area, and then New Orleans area, which I think is remarkable, right? Because New Orleans isn't actually that big of a city, but it's obviously a really important cultural city. We can also see that African American English tends to be the main source of these new words. I think that's an important thing to note. I think we can actually see like 3 distinct hubs in the Southeast. So we actually see some real distinction within African American English, the Atlantic, the Deep South, and the Gulf Coast. And, you know, those actually align quite well with historical population patterns related to slavery and related to the cotton, the tobacco, and the sugar plantations. And I think those are basically what underlie those 3 regions. We can also see that the diffusion of emerging words, so how they spread out, does reflect geography and population density as predicted by the wave and the gravity models, but also that it's even really more closely or really constrained by these regional cultural patterns, right? So that we see that words spread within cultural regions. And you know, lastly, we can see that new words tend to spread within these cultural regions before diffusing more widely. And that's likely in part because of the social meaning they express, but I think we shouldn't say it's all social meaning. And, you know, like say Croft would argue that the actuation of new words, of new forms is functional, but the spread is social. And I think that's maybe too simplistic here. Like clearly some of these are marking social meaning. You could see why they'd spread within these cultural regions, and that does support that kind of view. But I think it's also because like the referential meaning and the functions of these words are more immediately useful to those communities, right? Because these are all culturally driven. And so it makes sense that the usages of these words would be more useful and more likely to take off in a given culture. Okay, just to wrap up in the last minute here, I want to say first that, you know, what we see here is that lexical change is incredibly complex. that there are really many reasons and ways that word usage changes over time, both in general and for emerging words. And when you zoom in, what you really see here is that these patterns are not random at all, right? Every one of these patterns is motivated by the meanings and the functions of the words, the meanings and functions needed by the speech community that uses them. They're all driven by cultural change, by technology, by fashion, by by entertainment, by needing to mark social identity, etc., and by the actual, in some case of social media and online communication more generally. And that includes not just the actuation, like I said, but even the spread of these forms. I don't think we can say the spread is just sort of random or social. They're spreading because they're useful. And so in other words, what we see is direct evidence of how communicative pressures shape the structure of our lexicon in a really continuous, dynamic, and complicated way. I mean, even down to, I kind of want to hit this point because I think it's an interesting one, even down to kind of creating new word classes, right? These are not just performance issues. These are really about competence and about our kind of underlying language models. And computational sociolinguistics, kind of like Bruno argued, really gives us a way of doing this kind of high resolution diachronic linguistics. And there's no doubt these opportunities are increasing over time, as more and more data comes online and from a wider and wider registers, more languages, more dialects, etc. And I want to stress once again that analyzing these really large corpora does not demand complex analytics, right? What I did here was really simple. Even things like PCA and stuff are really simple methods, broadly speaking. It's like one line of R code. Big data actually kind of maybe paradoxically allows for really simple analyses, like in this case. The last thing I just want to end with, because it's always kind of a question people have, and that is does this stuff generalize, or this isn't really generalizable? And I want to stress that we haven't generalized here past Twitter. This is, a corpus of Twitter, and we can generalize to Twitter. But I think it's really important to say this, that whether these things generalize is sort of an open question. And that's because there's no other varieties of language for which we have this data. But as more spoken language gets online, as more registers gets online, as more historical data gets online, that we have access to it, we're going to be able to assess the generalizability then. And that's really the idea of computational sociolinguistics. It's not the same as doing CMC linguistics. It's what we use because it's what's available. But it's really taking advantage of these huge amounts of data to try to understand new questions. And I think language change is one of the most exciting areas. Thank you very much.